Hello, this is a video to talk through Learning Target 4 on the review for checkpoint 2. We'll do definitely question 1 and maybe question 2 as well. So here's the scenario in question 1. Let's say a basketball player usually makes 47% of her shots. And you're curious about whether that's different when her first 3 attempts are successful. So the first thing we're going to do is write null and alternative hypotheses to test this. So the null hypothesis should generally say that there's no difference or no change. So here, that would mean that the player would make 47% of her shots when her first 3 attempts are successful, just like she does. Okay. What we're writing a hypothesis about is a proportion, right? The percent of shots she's making. So we'll go with P, and our null will be that it equals 0.47, which is her usual. Okay. The alternative is something else that we think might be going on. Here we need to look for some context clues about which kind of test we're doing. Here, it says you wonder if her rate is different when her first 3 attempts are successful. It's not making a guess as to whether it's greater or less, just different. So that tells us that the alternative hypothesis we should use is P is not equal to 0.47. Right? Could be greater, could be less. We don't really have a guess here. We just think it might be different. So let's move on to the next part. So here we've collected some data, and we find that she makes 62% of her shots in the games in which her first 3 attempts were successful. So let's say we did some simulation or looked at a binomial of this, right? So we have a distribution. It assumes the null hypothesis is true. Right. And we are out here at P equal 0.62, sorry, P prime, right? This is our sample. Right? And we calculated the probability that this or a more extreme situation happened. And since our alternative hypothesis says it can be extreme in either direction, we want both tails. This one, and let's mirror to the other side, this one. So our p-value is the probability of a sample in the shaded regions if our null hypothesis really is true, right? And we found that that probability is 0.16, or that's what we're told in the problem. Right, so this is pretty close to what it's asking for. So if we kind of finish this sentence, there's a probability of 0.16 that, assuming the blank hypothesis is true, right, what we assume is true is the null hypothesis. Right, where do we go from there? What is this a probability of, right? Right, that we would see our results or more extreme ones in in a similar sample just by chance, right? Saying that even if the average is 47%, right, we could get something as higher than 62%, and as lower than 32%, 16% of the time. Right, so we're looking for samples with results as extreme or more extreme, right? Here, extreme means kind of far from the null hypothesis. Okay. Right. And so this asks, at a 90% confidence level, what do we conclude? Right, a 90% confidence level is at a 0.10 significance level. So we're comparing our p-value to an alpha of 0.10. Right, so 0.16, our p-value, is greater than alpha, which is 0.1. Right, so we do not reject the null hypothesis. Right, our results are too likely to happen by chance if the null hypothesis is true for us to conclude that the alternate hypothesis must be. Okay. Let's think about another question. So here we want to test whether the percentage of Fitchburg State students who get at least 7 hours of sleep is 50% or greater. Let's write our hypotheses for that. So our null hypothesis is that it is 50%. I think that's one possibility. The other possibility here was greater. So that's our alternative. P is greater than 50%, right? We would normally write this as 0.5 or with P greater than 0.5. The next question asks if this is one-tailed or two-tailed. Right? And one-tailed means that our alternate hypothesis uses greater than or less than. Right? Two-tailed means it's using not equals. Right? And this comes from a picture like this. Right here, we were using not equals. So when we found a p-value, when we were looking for samples as extreme or more extreme, they were on both sides. But if we have a guess as to which direction it goes, then we only care about one side, right? We would only care about something like this versus wanting the tails in both directions. So here, we have a one-tailed test because we think it might be greater than 50%. Okay. And so let's think about this as a 0.05 significance level, which is typical in a lot of studies. Right? And we found a p-value of 0.04, the problem says. So we're going to compare those. 0.04 Is it less than or greater than 0.5? It's less than. Right, so our p-value is low compared to our significance level, our threshold, right? And that means that this kind of result, the result we found here, wouldn't happen very often if the null hypothesis were true. So we can reject the null hypothesis because our data has a low probability of occurring if the null hypothesis is true. So we conclude that the alternate hypothesis is the case. Right, and here we didn't actually see the data, but like up here, it would be some kind of poll, we would get some kind of percentage, right? And then we could do the test using the applet that we've been using in class, or a simulation. Okay, please let me know if you have any questions.